and wear a mask and everything. So you can see our sort of peaceful transition of power, which is important to the political scientist in me. And when we're done with that, we have an announcement by our Charitable Trust Committee, and then we're going to get to our speaker, Dr. Blake. So Jeff, if you and Troy can begin sharing your screen and showing that video, that would be wonderful.
You do. Okay. I'm going to do this one. Share.
Okay, we don't have the sound yet.
Okay. So thank you very much. Let me put the sound up here. Go back there. Can you hear it?
We can see the video, but we can't hear it.
Okay.
Or it's not loud enough. It still doesn't have any audio.
Martha, at the risk of overstepping, I could share the same video.
Do you have the video?
Well, it's a YouTube.
Okay.
If that's okay.
Yeah, that's great.
Absolutely. Can you hear us?
Yeah.
Okay, so you'll just go to the Kiwanis Club of Augusta, Georgia YouTube page, and it'll be right there. It's nice having high tech.
Can you turn up the volume on it? Can others hear it? I can't hear it very well. No, other people are not being able to hear it very well either.
Are you able to hear it?
No.
Well, let's punt and we'll send out a link. Everybody can watch it on their own.
We'll share that in Kiwan Notes where everyone can see. That might be a little less awkward.
We're sorry.
Oh, wait a minute, I got it.
Okay.
I didn't click the share computer sound button.
Oh, perfect. Okay, here we go.
Okay.
Governor. Welcome everybody, and thank you for joining us for our induction for the 2021 year for Kiwanis. So thank you very much. Looking forward to having everybody see this on our Zoom video call. And thank you guys for all being here today on this wonderful day. We've got the bells ringing in the background for us. That was in honor of us, right? Okay. So at this point, I'm going to go ahead and turn it over to our Lieutenant Governor, Jeff Drake. And Jeff, you're going to go ahead and take over the induction ceremony.
All right, great. Thanks, Jeff. So it's my pleasure to be here to recognize outgoing officers and new officers coming in. So we appreciate all the directors and officers who have been holding office, and we'd like to thank them for all that they've done in this last year. Thank you for your service to the club and being a part of this club. And we thank you for your contributions in the past year. And now let's go to installing our new officers. So first we'll have our new directors. So if I could have those new directors come up to the table. I will have a short speech, and then we'll have Lowell give them a pen.
You want board of directors, or you want board people first? No,
let me recognize second year first, and then we'll have first year come and get a pen. So Chuck Lanier, Bill Bennett, Catherine Robertson, and Dalton Brennan, if you could come, and Angela Chang, if you could all come forward. And these are our board of directors who have served 1 year and will be serving their second year on the board of directors. So thank you for your first year of service, and we look forward to you leading us this second year of service. We have a pin for you.
Thank you very much.
All right, thanks. Now, so our first year directors, we have Catherine Robertson, Sarah Bell, Mark Alberton, Zadok Williams, and Joe Sharina. If you could come forward. So the board of directors of a club is comprised of you, the elected directors, and the officers. The board of directors handles most of the business of the club, an important responsibility. You'll be setting the strategic direction, implementing club policies, and improving the club's budget, supporting the committee activities, and overseeing the administrative tasks of the club. I know you will accept these responsibilities with a desire to see that this club will have its best year ever. Thank you for stepping up to play this important role. It's my pleasure to formally install each of you as a director of this club.
Mark? Sure. Stand up. Thank you. Thank you.
Thank you very much. Thank you. Next, we'll have our secretary/treasurer installed. So if we could have Lowell Dorn come forward. As the club secretary, you're the master of the details. Your role in handling club affairs, the details of the club and board meetings, the reports, the correspondence, and records is essential for this club to run smoothly. So thank you for taking on this important role. And then also, as the treasurer, it's your role to deposit and disperse the funds of the club upon the discretion of the board of directors. You also report on the club's finances at each board meeting. Thank you for stepping into both of these significant roles. I have formally installed you as the secretary and treasurer of this club. Now, if we could have our Vice President, Derek May, come forward. Derek is an officer of the club. You contribute your vision and ideas to your club's leadership team. In the absence of the president, you will preside over club meetings and board of directors meetings. You will also be responsible for coming up with all our speakers, and we appreciate that and help him out with that. I formally install you as a vice president of this club. President-elect, Troy Lanier. Troy, you've been selected to lead your club during the following year. As you serve on this club, on the board this year, take advantage of opportunities to learn about the president's role, build relationships, and plan for your year as the president. Thank you for your leadership and dedication. I hereby formally install you as the president-elect of this club. Congratulations. We could have the immediate past president come forward, Jeff Aslan. Jeff, our club has benefited from your continuing, will be benefiting for you continuing one more year as the immediate past president. Your experience as club president this past year will empower you to be an essential mentor and colleague for your successor and a valued advisor on the business of this club. It's my pleasure to present to you your past president's pen, and by doing so, to charge you with sharing your wisdom and lending a hand as you remain a member of the board for one more year. Congratulations to you on your excellent work and dedicated service over this past year. We thank you for your continued dedication to our club. Thanks.
All right, good.
President, Martha Ginn. Martha, you have been elected to the highest office your club can bestow upon you. It is an office of great honor and of great responsibility. The success of your club in this new year will depend upon your leadership at club and board meetings and as you counsel and inspire your club's committees. In our community, you'll be the face of Kiwanis and your club. Guided by your club's vision, you and your board will set goals for improving your club members' experience and increasing the impact of your club's service in the community. Thank you for dedicating yourself to this leadership position. I hereby formally install you as the president of this club, and I sincerely hope that your administrative year will exceed your expectations. Congratulations. I want to congratulate your club on the excellent board of directors and officers installed today, and wish for them and your club a most successful year. Thanks to each of you for stepping into your leadership roles, and thanks to the club members for your support of these leaders. I can assure you of complete cooperation and assistance of the Division District and Kiwanis International officers and committee chairman as your Lieutenant Governor for Division 6. Thank you.
I want to make a presentation of a pin to our Lieutenant Governor and also a member of our club, and thank him for his service he's done in the past and what he will do in the future. Thank you.
I've got a quick presentation too. Martha, come on up. This is a big presentation for you for 1 year of fabulous speakers. I know it kind of threw you some curveballs trying to get speakers that could do video and all that, but I'm going to have you go ahead and open that up. You'll have to cut it off. But, you know? Okay, there you go.
Maybe not.
My daughter wrapped it, so.
Okay, maybe so.
There we go. All right, there you go. You got it.
This is my very own Zoom.
I think I know what that is.
You know what that is?
I think I do too.
Close.
Oh, nice.
So there's her very own Zoom photo. Everyone she did. There you go.
That's awesome. Thank you.
All right. Congratulations. Thanks again. All right.
This is when we get to the Zoom format.
Yep. That's right. Well, good job.
Thank you so much.
Yes, thank you for doing all that. And y'all, thank you very much for making this happen today. This really meant a lot to see you guys. It was really important to be able to, rub elbows and share lunch. And thank you guys for a fabulous year. Just really enjoyed it, and can't wait to see what you're gonna do. Great things.
Jeff, thank you. We all
Thank you.
Jeff kind of had what you say, kind of an average year, wouldn't you say?
Okay, thank you, Dr. Blake, for helping us through those technical difficulties. And hopefully everyone was able to vicariously enjoy our afternoon together in the transition of power. Nothing is normal this year, but we are doing our best to embrace it. At this point, speaking of sort of returning to normal, we are beginning our charitable trust campaign drive. And so I would like one of the co-chairs, Amiga Lockins, to unmute and speak to the club for a minute about the charitable trust drive this year and how we're going to be handling donations.
Hi, everyone. It's good to see you all. This has definitely been a year of exciting things and changes. However, with that being said, there are some things that do not change. And one of those things is our love for our community and charities. And we would love for you all to continue to support charities and support the club by donating to the charitable trust. In the past, we have asked for $100, and we are still asking for at least $100. However, if your hearts and pockets feel so to do so, please feel free to donate above and beyond that. Particularly in this time, since we have cut down, at least temporarily, our dues for Kiwanis. Take advantage of that time and reach down into your pockets and hearts and maybe give those extra funds to the charitable trust. We do a lot with those monies, and it's still an important thing, especially now. If ever time has been needed, now is the time. Some of the charities that we have support in the past includes Christ Community Health, the CSRA Humane Society, Society Historic Augusta, the Lydia Project, the Jewett Park Clinic, and the University Hospital Speech and Hearing Center. And I look forward to see whatever additional charities we are able to support. So thank you all for this time to speak to you all. Hopefully throughout this year, you'll see more coming as we ask you all to continue to donate. Thank you.
Thank you, Amika. And you can mail your charitable trust donations to the P.O. box that you used to send your dues just make sure you either include a note or on the memo line whether your check is for the dues or whether it is for the charitable trust, so that Lowell can keep the accounting records straight for all of that. So at this point, we are now to the point of our program which you are all here for, and that is our amazing speaker. I'm going to be doing the introduction, although I hadn't planned to be doing the introduction because we had some technical difficulties. So it's going to be a little improvised, so I hope that you will work with me. Our speaker for today is David Blake. He's a PhD at Medical College of Georgia / Augusta University. He's an assistant professor in the Department of Neurology, but he is also part of the Brain and Behavior Discovery Institute. His primary research interest is brain plasticity caused by learning in adults. So he is literally a brain scientist. And he teaches courses on neuroscience. He has his PhD from Johns Hopkins and his Bachelor's of Science from Duke. He's going to be talking us today about the coronavirus. I don't know how many of my fellow Kiwanians are on the Twitterverse, but if you are, I recommend that you follow Dr. Blake, because he provides all sorts of very important science-driven information that guides my behavior and my decisions as to what I'm comfortable with regards to adjusting to this new normal and coronavirus. So please join me in thanking Dr. Blake for helping us through our technical difficulties as well. Dr. Blake, I'm going to hand it over to you.
All right, I'm going to see if I can share the screen and go to full screen. Maybe a thumbs up from someone, maybe, if it's working. All right. So my talk today is on tracking the COVID-19 pandemic. My introduction was somewhat accurate. I'm a full professor in the Department of Neuroscience now. I started here at Augusta University 15 years ago after spending 10 years at UC San Francisco. My field is brain physiology. Right now, I'm mostly working on deep brain stimulation to treat Alzheimer's disease. But I've been doing a lot with the COVID pandemic, and I have my social media contacts on the front, and I will email those to your club president so that these slides can be sent out so that you may look at them and try to remember as much as you want. I was giving a talk on brain physiology about 7 years ago in Europe at a layperson conference on things we needed to think about for the future decade. And it was called BioVision, the conference. And I talked about brain physiology and went to one of the other symposium sessions. It was on pandemic science. And I became really fascinated by the mathematics involved. As part of my profession, I've had to become extremely well educated in statistics and probability. And so I was following along with the math and thought, actually, it was pretty neat the way that it could be used to sort of track things. And then the next symposium speaker got up and I became completely terrified because the speaker covered what would happen if the 1918 flu were to happen for the first time today. The world is much more connected today than it used to be. And it would take us too long to develop treatments and too long to develop vaccines to prevent it from running the globe. And so from that point on, I started tracking each new infectious disease that came along using some of the metrics that came from that conference and to see, is this going to be the big one? And when COVID-19 came, certainly by late January, when they shut down Wuhan, it was very clear that this was going to be a big one. So I've been running statistics on COVID-19 and posting them on social media. This is a plot I made this past weekend. It shows the number of new cases per day in Richmond plus Columbia County. And it's organized by symptom onset date. So this is what's called an epidemic curve, where you try to see what the prevalence of disease is in an area. And I pulled this data from the Georgia Department of Health. You can see our summer peak is occurring just before the beginning of August. And you see this little dashed line over on the right. Because this is an epidemic curve, the new reports get predated to the date of symptom onset. And so the last 2 weeks are a little bit incomplete. Usually when I post this, I say something like, well, the last week or two, it seems like things have been pretty stable and we're at about a third to a quarter of our summer peak levels. That's also consistent with what's happening in our hospitals right now. So I'm going to talk about the stuff that I've been doing in statistical epidemiology. Now, because of my background in statistics and my interest in the epidemiology, I think I can carve out that tiny little slice of infectious disease science and be useful and helpful. But I'm very cognizant that the professionals in this are the people who work in infectious disease for a living. The infectious disease epidemiologists, doctors, and scientists. So that an epidemiologist is somebody who's in a community-facing position. They help people with infection prevention. They help people with guidelines for social distancing, for seeking treatment. How long should you stay in isolation? The infectious disease boarded medical doctors are the ones at the hospital that will attend and make sure that your case is being handled properly. And the scientists, they're the ones that are developing, studying the virus, studying how it spreads. They're developing new treatments and cures. And all of these types of people are trying to help advise the public. And I follow a large number of them on Twitter. I have all of their Twitter handles at the end of my talk, which I hope if you're interested, you can seek to get some of the expert advice that they might have. So the first question that I was really interested in was how many people were actually getting infected. And it's different from the case reports. The case reports tell how many people tested positive, but we certainly can appreciate at this point that many more people get infected than those that test positive. So to illustrate that, I had this graph on the left in front of you is from New York City, data up through May 6th. And on May 6th is when they published their antibody surveillance study. So the orange curve here is the sum of all the confirmed cases up to that point, organized by the fraction in each age group. So you can see that more than 50% of the people confirmed in New York City were over age 65 through May 6th. And the antibody surveillance is a different form of measure of the number of people that were infected. They take small blood samples from randomly selected people and see what fraction in each age group test positive. That indicates that they were previously infected by COVID-19. And you can see that these don't match. The most infected age group was the 18 to 44 age group. And so by looking at these two distributions, you can infer that we're missing infections in younger people much more than we are in older people, at least in the early phases of this pandemic. And the under 18s, it's really prevalent. They're missing 60 times more infections for the people under age 18 than they are missing those in the 65 plus age group. So that was early on, but we bolstered testing, and you can use the same data from New York City and look at what happened over the summer. So this is June, July, and August data from New York City, and you can see that the antibody surveillance and the confirmed cases curves, they kind of have sort of the same shape now. They're at least pretty close. And there's still a gap for the under 18 age groups. And so by looking at these and also calculating the number of the ratio between the antibody surveillance and the confirmed cases, you can see they're identifying something like half of all of the cases in the 65 and older age group in the summer in New York City. And they're getting about one case for every 3.8 infections in the next lowest age group and so on. Working their way down, they're getting about 3 infections for every case, or 2 additional infections, 2 missed infections for every case that they identify. So by going through this process of making these calculations, we can get an estimate of how many people are infected at any one point in time, which is what I was going after. Nationally today, we're missing 2 infections per case. In Georgia, we're missing 4 infections per case. We don't test the people who are less vulnerable as well as other states do. So I use those to make these plots where you can see now the x-axis is the percent currently infected. The y-axis is this other measure, cases per fatality. Now, you have to think about that for a while, but in a normally structured environment, we expect that the same number of people, fraction of people will die of those that are infected. But because we all test differently, it becomes misleading. The states that test really well, they go out and find a lot of vulnerable people who are infected. And that generates a lot of cases. Their case numbers can get very high. But a smaller fraction of those cases then die. They have high cases per fatality. Pennsylvania is a good example. They go out and they test very, very aggressively, and they find about 120 infected people for every person that dies in the state of Pennsylvania. Georgia is down in this little group at the bottom in states that don't have very aggressive testing. We're finding about 30 cases for every person that dies in Georgia. So what happens when they find those extra people in Pennsylvania, if the testing is also rapid, then they can ask them to isolate, and they can ask their probable contacts to isolate, and that helps break the chains of transmission, and it helps reduce the total number of people who are going to get infected in the next generation of infections. And we talk about isolating. I think it's really important to make a point that epidemiologists make over and over again. Isolation cannot be viewed as a penalty. One of your club members recently was infected and had to isolate. I know because I just saw him on the Zoom call. And it was a little bit like a penalty because there's not really good support for the people who are isolated. If your friends or neighbors are isolating, you can really do something positive by helping them out while they're isolated. Take them over dinner some night, offer to go to the grocery store for them. Because when people are supported when they isolate, they're not reluctant to go get tested. And people need to sort of embrace the process of public health that'll help break the chains of transmission. So the next thing I wanted to show you guys and gals is schools. So I did an analysis after schools had been open for a while to see what's going on in Georgia. Are schools opening really a good thing or not? Now, this is difficult to do a clean epidemiology analysis because you don't have a good control group. It's not like you can take two identical counties and put one of them in school and one not in school. But we did have some counties in school and some counties with extremely socially distanced schools. So on this picture of the state of Georgia, this county map, all of the counties with an O in them were the ones that I used that had only virtual school options through the beginning of October. And the X's are nearby counties that I selected because they have similar demographics, similar geography, similar numbers of people. You can see down in Chatham County, because Savannah is so much more population dense than the others, I had to pick 5 counties to get as many people to match up with them. So I just ran these numbers this morning, and the graphs of their epidemic curves look like these two. If you look at the y-axis, the top one is in-person school. The bottom one is virtual school. And if you try to calculate the ratio change from the middle of August to the beginning of October, then you get a slight advantage for the people with in-person school. They suppressed the virus slightly better than those counties that had virtual school, which is, of course, a surprising result, but it's not a very big difference. I wouldn't hang my hat on that difference, but I would say that there's not any evidence that having school is causing any kind of out of control sort of outbreaks in the counties that have it. And it should certainly show up at this point because a very large fraction of each county is actually in school. In Columbia County, where I reside, there are 25,000 kids in the school system, and about something like 17 or 18,000 of them are in school. That's more than 10% of the county that's in the schools. So the fact is that we are not seeing big problems from having school, which makes everybody feel a lot better about it, I think. And was surprising to me. I thought we were going to have much more problems with schools than we did. But when you have the data in front of you, you've got to let the data drive the policies. All right, now I'm going to go on to a more general epidemiology of COVID-19 and hopefully clarify some things or maybe present some things to you all that you maybe haven't been thinking about. It's obviously a coronavirus. In America, 1 in 14 people becomes hospitalized. 1 in 14 people who's a confirmed case, who's tests. 1 in 5 of those hospitalized becomes a fatality. At the very beginning of the pandemic in the US, 1 in 3 people hospitalized became a fatality. Now it's 1 in 5. The problems are linked to age, but there are different ways to look at it, could be better explained by comorbidities. And the comorbidities that are identified are cardiovascular disease, COPD, smoking, obesity, and kidney disease. Now, how it relates to age is shown in this graph on the bottom, which is from a group at Dartmouth that's doing epidemiological analysis of all of the data coming from all the countries of the world. And they find that it fits an exponential curve really well. That is, you can tell somebody's infection fatality risk, the percentage of people that are infected that will go on to become a fatality based on their age. For example, the people who are 85 years old, about 14% of those who become infected will become a fatality. Now, because only about half of those actually get tested, it's more like 1 in 2 or 1 in 3 of those above age 85 that test become a fatality. So that's pretty bad. For people who are younger, it's not as bad. It goes down as age gets younger and younger. You can see down, it's in that sort of 1 to 2% range for people who are 65 years old. Now, people have made a lot of comparisons between COVID-19 and the flu for this infection fatality risk, or the ratio between the number of infections and the number of fatalities. And so this next slide shows a comparison that was done by a data scientist on Twitter, Mark Bevan. His Twitter link is in the upper right, Zoranak. So what he's plotting here in blue are the last 6 seasons of the flu in the US, the infection fatality risk estimated from the CDC from each of those 6 years, these 6 blue lines that overlap each other. And you see the flu, unlike COVID-19, has an uptick here for younger people, especially if very young people get the flu. It's very serious. Older people get the flu, not as serious as the young people. The red curves up on the top are the infection fatality risk estimates of a whole bunch of different academics for COVID-19. And so when you compare them, you see he drew the ratios on here. For people over age 50, it's more than 10 times higher fatality risk for COVID-19 than it is for the flu. But even when you're at age 30, the average of the COVID-19 estimates compared to the flu seasons is still a ratio of 3. COVID-19 is still 3 times more fatal than the flu if you're 30 years old. And when you get down to age 20 is where, or less, is when it sort of becomes a bit more of a mix. So this is a very bad pandemic bug. It certainly merits its justification for some of the restrictions that are being called for. On to more epidemiology. COVID-19 is overdispersed. What does that mean? That's a funny word, and most of you have probably never heard it used to refer to a virus. It talks about the distribution of the number of people infected from each case. So the next generation infections. If you are infected, what's the distribution of the number of people that you're going to infect in transmitting? And so what overdispersed means is that a small number of people generate really large numbers of infections of others, but most people don't infect anybody. And that's what's shown on this curve. It's this plot. It shows 2 different studies, and 60 to 65% of the people in each of the studies didn't infect anybody else. Most people don't infect anybody else, but there are these people out here that are infecting 10 or 11 others. So that's one of the things that's a little characteristic of COVID-19 is this tendency for there to be super spreading events. What you would say if one event resulted in 5 or more people being infected. So we need to be cognizant of this. This is very different from the flu. The flu is an underdispersed virus. One person will infect 1 to 3 others, and there's very few super spreading events. And we'll talk about some of the reasons for that in the next few minutes. COVID-19 spread, this comes from that same review, which was written by Muj Sedek. I think I have her name on the next slide, but it's a review of all the epidemiology literature. It was published about 10 days ago. Spread occurs 18.7 times more easily indoors. So they pulled contact tracing data from all of the nations that do lots and lots of studies of contact tracing, how one person how they can figure out who transmitted to other people, and then they collate all of their results. And it's just 18.7 times more likely to happen indoors than outdoors. And I saw your ceremony was an outdoor ceremony without many people there. That's really safe, much safer than doing it indoors. And contact tends to occur, or transmission tends to occur, when there's prolonged close contact, especially without masks, especially without ventilation. So there are some clues here that I'm leading into that about how we can respond more effectively to COVID-19. Here's that next slide from Muj Sedek, and there's actually a reference up on the upper left. That DOI number can lead you to her summary paper, which they wrote to summarize all the available COVID-19 data. This slide shows when people are really infectious. The high infectious period ranges from 2 days before symptom onset to 5 days after. That's the average. It can, of course, be a day or two different from that in individual people. At 10 days after symptom onset, you're no longer considered infectious provided that you've been fever-free for more than a day. And that's the CDC standard for ending isolation is 10 days after symptom onset, provided that you're fever-free. And the evidence for that is that they have not been able to culture live virus from anybody who's 10 days after symptom onset. So they think you just can't transmit it to other people at that point. Now the testing can still detect it. There's sort of dead virus present in the biological samples that they normally take for testing. So that RNA sequence can still be found, but the virus itself is not alive coming out of somebody's mouth at that point in time. So there's different ways that viruses can spread, and they're summarized in this slide. Aerosols, droplets, and fomites. And my wife actually gets mad at me when I use the term fomite. She says that's a funny buzzword and nobody understands it. But a fomite surface is an infected surface. And fomite transmission is when you get infected from touching surfaces that have virus on it. So for example, if you have the flu and you touch your hand to your mouth and then you touch a doorknob, somebody else touches the doorknob, they touch their hand to their mouth, they can get the flu. Fomite transmission is very effective for transmitting influenza. There is droplet transmission. So as we breathe, little bits of water come out of our mouths from deep in our lungs, and they carry other things that are in our lungs with them. And the droplets are more than 5 microns in diameter. And as inferred from their name, droplets drop. And in most cases, they'll hit the ground within 6 feet of the person that emits them. And if people are speaking loudly or singing, they can actually push droplets further than that. But this is the basis for the 6-foot rule, is the thought that there would be droplet transmission. Aerosols are little bits of water that are less than 5 microns in diameter. And I don't like to call them droplets, even though they are small bits of water, because they don't drop. They float. They float in the air. And there is now really strong evidence that aerosol transmission is the dominant mode of transmission for COVID-19. So aerosol spread is greater at close range. So the air that I breathe out is, of course, going to be in higher concentration near me than further from me, which explains why prolonged, sustained close contact is the dominant characteristic of spread. But it can be long range if ventilation is poor. And CO2 levels provide an easy check on ventilation. And I'll talk about that a little bit at the end. I'm going to show a CO2 meter that I brought with me. Larger facilities can use ASHRAE standards. ASHRAE is the American Society for Heating, Refrigeration, and Air Conditioning. And the Society for SARS, which happened before COVID-19, they developed a new set of standards for aerosol infectious disease for air handling. And those standards are up. HVAC engineers are studying them. And you basically increase the air exchange rates. And you can also do different forms of disinfecting the air to make it safer. But I wanted to make this point. I just showed you that this is an overdispersed virus. If you take away those super spreading events, if you prevent one person from transmitting it to 5 or more others, then COVID-19 will go away. And all the super spreading occurs indoors in stagnant air, poor ventilated air. So to think about aerosol spread and when stagnant air, what fraction of the air that you inhale was exhaled by somebody else? That's what we talk about when we talk about stagnant air. And so the way that you get rid of stagnant air is that fresh outside air is brought into your HVAC system, and it displaces air that people have exhaled. So these are the safety advice for COVID-19. The first one are what epidemiologists have been saying for a long time: wear a mask, wash your hands, and watch your distance. But that doesn't really address aerosol spread. If you're in a small, poorly ventilated space with somebody who's infectious, then doing all 3 of these things can't keep you safe. You're going to be breathing in the air that they exhale, and it's just going to be unavoidable. So we have to talk about ventilation. The first thing you can do is move all possible activities that would be held indoors to the outdoors. And in Georgia, especially this time of year, that's often an option. If that's the only thing you do, you'll reduce transmission by a factor of 18.7. You can check and improve your ventilation. And there are energy saving devices. ERV and HRV devices are buzzwords that you can Google. They are devices that move the air from inside a building to outside the building and vice versa, while not affecting the HVAC. So if there's cool air inside, that it'll exchange heat with the air coming from the outside. So you'll basically get a bonus of ventilation without incurring much of an energy penalty. But you can, of course, open windows if it's comfortable enough to do so. And in Georgia, this time of year, opening windows is your best option, your easiest option. If you're in a situation where ventilation can't be improved, you can use HEPA filters, and there are other air disinfection strategies that you can try to employ. And I have a note here to be careful about places where you might find stagnant air and not think about it. If you're in a car and the air is on recirculation, the air is incredibly stagnant. If you have 3 or 4 people in a normal passenger vehicle and one of them is infectious, there's no avoiding it. But if you have that same situation and the windows are rolled down, you'll have good ventilation. And so there are ways that you can get around that. Portable buildings and old buildings also tend to have poor ventilation. Most of our houses don't have aggressive ventilation. They're perfectly fine with 2 or 3 or 4 people there. If there's 20 people inside my house, then it will be stagnant air. So we have to be conscientious that gathering in our homes, unless you know that your air is being ventilated well, that's a risky environment. If you gather on the back deck instead, possibly with some heat to keep people warm, or something to keep bugs away, or what have you, to make you more comfortable outdoors, that's going to be safer. I had a little slide I put in here about the new treatments that are being developed. This is the treatment the president was given. It's not yet approved. And it's called a monoclonal antibody cocktail. And I thought I'd explain what it was and how it works, because I think it's going to fundamentally change how mortality happens. I think it's really going to save an enormous number of lives. So the panel to the left shows a polyclonal antibody around a COVID-19 virion. The virion is the intact virus particle that can infect people. The virion has a fatty capsule on the outside with spike protein sticking out of it. And on the inside, it has its RNA sequence. Some of these antibodies match the conformation of the spike protein and bind to it, like this one in the top center. Many of them don't if you have a sample from convalescent plasma. So the convalescent plasma trials did not seem to have an enormous effect on progression of the disease, and they think that it's because it didn't have a high concentration of antibodies that were selective for COVID-19. So how can you get more that are selective? Well, you can use monoclonal antibodies. So if you took the cell that made this antibody and you cloned it so that you had a lot of identical cells producing the exact same antibody, that's a monoclonal antibody preparation that these companies like Regeneron produce. And so they can produce a high concentration of antibodies that really prefer COVID-19, and that'll help get COVID-19 out of your body. Now, when they did these in viral culture, what they found was the virus could mutate as it replicated, and it could avoid detection. There could be escape strains that were created because the antibodies are all identical. Unlike the response of your body, they don't identify all the different presentations of COVID-19. They only know one presentation of COVID-19. So what Regeneron did, and this is the same as was done by Eli Lilly and AstraZeneca, they take 2 monoclonal antibodies and they recognize different conformations of the spike protein in COVID-19. And because they recognize 2 different aspects of the spike protein, it seems like they probably cannot create an escape mutant. They think that if you take these, it'll simply get rid of all of the virus in you and you'll be healed. So the president took these a week ago Thursday, and they're very long-lived. The standard half-life given for the immunoglobulins in the bloodstream is 21 days. Through at least 11 days, they really get the levels of virus in the bloodstream very, very low, undetectably low. And so it's a little bit of a mystery of what's going to happen now. People don't really know if people that receive these treatments are going to be immune, especially from now on. If you had a lot of virus in you and very early on you were injected with a Regeneron cocktail, it could get all the virus out of you and you might not develop your own antibodies. So you might be just as susceptible to catch it again. But of course, it would get rid of the sickness. And especially in a vulnerable person, that's a really, really positive thing. So this is the slide, and I'm going to send these slides to Troy Lanier so that he can send them to you. But here's a long list of the people that I follow on Twitter that are experts in infectious disease. These people have spent decades of their lives working in infectious disease. So now I'm turning on my CO2 meter so I can show you that at the end. And I'll stop the sharing. So this is my CO2 meter. It's doing a countdown now for another 20 seconds, and then it'll tell me what the CO2 concentration is in my room. So why do we want to look at this? Well, the CO2 concentration in the outdoors is 410 parts per million. If it goes up above 410 parts per million, that indicates that more of the air that you're breathing is somebody else's exhalations. It's called rebreathed air. And the larger the fraction of rebreathed air, the less safe it is for transmitting COVID-19. I'm at 622 in my office right now, which is below the level of 650 that they say ensures that the fraction of rebreathed air is small enough that you can't catch COVID-19. Of course, I'm the only person in my office, so there's no possible way I could get transmitting COVID-19. But if there were multiple people in the same room, you can check with the CO2 meter and make sure there's enough ventilation. If not, you can seek to address the ventilation. So just by walking around with a CO2 meter at times when there's lots of people present in the same rooms indoors, you can see which rooms have stagnant air. And those rooms with stagnant air are the ones where you can seek to address the ventilation and get rid of, again, if we ventilate well, the super spreading events will go away and COVID-19 will not have enough transmissions to continue. It'll simply go away. And at this point, I'd love to take any questions that y'all might have.
Great. Thank you, Dr. Blake. If you have a question, I think we're small enough that you can just go ahead and unmute your microphone and then ask your question.
Hey, Dr. Blake, this is Amika. Thank you again for the presentation. Real curious, so the CO2 reader, is that something I can get off the internet and hypothetically walk through the courthouse where we do a lot of our business in a particular courtroom to see how well the ventilation is in that particular room? Is that what you're saying?
Absolutely, you can do that. The technology is very mature and robust. They cost about $140 on Amazon. They're available right now. And one CO2 meter can serve a large number of places. And if you're down in a building like the courthouse, there's HVAC monitoring there, I'm assuming. And so they generally have people there that actually do CO2 testing. They probably are not cognizant of the 650 parts per million cutoff, but they probably have such a device already there. I would start by talking to environmental health and safety. When I checked with the people at Augusta University, they told me that they actually are already checking all of the rooms, and they were unaware that 650 was a cutoff that they could use. But now that they know that, they're going to be checking the rooms where people who are infected have been present so that they can see if they identify any of them with stagnant air. Of course, you have to check them when there are people present.
Gotcha. Well, thank you. I will ask. Thank you.
John Bell would like to ask, Doctor, I have not seen good statistics of the relationship with age, assuming the people don't have a bad heart, a bad lungs, a bad kidneys as pre-existing things. Now, a fair number of my contemporaries do have those problems, but what's it like setting aside those comorbidities?
Right, so that's a great question and one that's suitable for a multivariate analysis. And the people have performed them, and there's some debate in the field. It is certain that at a certain age, if you lack comorbidities, that you're going to be much less likely to become a fatality than somebody that had those comorbidities at the same age. I wouldn't think of it as a get out of jail free kind of pass, but it's a combination of things. And if you're younger and you have those comorbidities, certainly that's risky. So the field hasn't really decided on the answer to your question. It's very clear that comorbidities add risk at any age. But the age itself, I think, should also be considered a factor. Maybe that's not enough of an answer, but that's the best I can do.
Hey, Lowell Dorn, he rides his bike, he rides his motorcycle, he plays his horn. Is he at risk? He certainly doesn't think he's as old as his birth certificate shows. Okay. Thank you.
I have a question. You said you're surprised that the schools aren't producing more cases, and looking at everything you said about like super spreader events, it seems like, I mean, unless they have really good air quality, they're sort of ripe for these. So do you have any, and I know it would just be speculation, but why they're not, and what about college campuses? How are they different than your K through 12 environments?
So, right, the K through 12, and indeed most places that have large physical plants, they actually have HVAC engineering controls, and they may not get their rooms to 650 parts per million, but they're not horribly stagnant in their air. And so I think that's part of the answer, and part of the answer is that the capacity is lower and kids are wearing masks. And colleges, what became pretty clear is that the number of people that live with you is a major risk factor. So I don't know if people are following how well Georgia Tech has done, but one of the major things that they did is they got people out of multiple person bedrooms. And with the exception of the fraternity and sorority houses, they have almost gotten rid of all COVID-19 on campus. They did a number of other things. They have mask mandates and they have a testing program, but their testing program is not as aggressive as many others. The number one place where people catch COVID-19 is in the household. And the number one risky activity in the household is sleeping in the same room as somebody else. Because of course, if it's an aerosol spread, the person you're most likely to be breathing the exhalations of is your conspecific that you're in bed with.
Okay, this is a different question Jeff sent me via text because we can't get his audio to work. But I think this is relevant too to the president now. What can you say about reinfections for people who've already had COVID? What do you know about that?
So there are a number of documented cases of people getting reinfected from COVID-19. And the way I like to explain it is you can imagine if a burglar came into your home and he was wearing green pants and had a gun in his hand and of course mugged you and robbed your house. And then the person came back in 6 months later with a gun in his hand again, but he's wearing orange pants. Would you recognize him or not? Well, if you were focused on the gun in the hand, you would recognize him. If you were focused on the pants color, you might not. And so our immune systems, they recognize anything foreign that they can in the invading virus. And if it's not something critical to that virus's function, then that can mutate and you can be reinfected. And there's a number of people who have been documented as getting reinfected. And reinfections have in many cases been more severe than the initial infections. But, it doesn't seem like that's happening like wildfire. We also don't know what happens with somebody who gets that treatment that the president received. It's clear that that's a supplement to the immune system. It's also clear that it removes the training for the immune system to recognize the virus. And so it's quite possible that people who get that treatment will be prone to reinfection. Of course, that's better to be not infected and a chance of catching it again than actually to have it, for sure.
Dave, good to see you. Hadn't seen you at church in 6 months. It's going to be a while, even though we're back in as well. As a country, the United States has done a much worse job of dealing with this than other countries in the world. The statistics bear that out. Moving forward, we can't go back, but moving forward, what 3 things can you think of as a country, not individuals, but as a country, can we do to try to address where we are now?
So the standard epidemiology response is test, trace, and isolate. Testing, we are not doing. People talk about how much we're doing, but the thing I like to focus on is how rapidly we're doing it. Because to break the chains of infection of COVID-19, you need to have very rapid test responses. And then you need to find out who their probable contacts are and isolate. And the isolation has to be supported, not just by the government, but that's something that all of us can really take a part in. The other thing I think is these CO2 meters. I mean, we know super spreading events are required to keep COVID-19 alive. In Japan, they had a very different response. They focused on the super spreading events. They contact traced all the people who were infected, and they went 2 generations deep because they were looking for super spreading events. When they found them, they addressed them. If you find a nightclub has a super spreading event, you make sure that nightclub addresses it. Maybe you can address that through ventilation. Maybe you can have an outdoor venue instead, something to prevent that kind of super spreader event from happening again. So they didn't have lockdowns and they have done much better than but of course, most of the Pacific Rim nations have had lots of experience dealing with infectious disease that we just haven't had in America.
Dr. Blake,
Oh,
Yes.
Dalton.
many folks around the world are working on vaccines. It occurred to me, what if 2 or 3 vaccines were produced that had varying degrees of efficaciousness? Is it possible to, if that were to occur, would it be any detriment to anyone to take more than one vaccine?
I don't think that it would, and it's almost a certainty that that's going to happen. The first vaccine to come out, just by virtue of being first, has no guarantee of being highly efficacious. But if it has some efficacy, it'll slow down the spread enough that it'll give us some breathing room, and that's a good thing. And certainly they will figure out how to make a highly efficacious vaccine within a year or two. And so I think that'll be the path that's most likely, is that we'll probably get poor efficacy vaccines, 50 to 70% efficacy, and we'll line up to take them between March and June next year. And it'll really put the brakes on COVID-19. And hopefully some of these other things, as we learn more about the virus, the CDC is just coming to terms with the aerosol spread that many places elsewhere in the world have already come to terms with. That is a really an Achilles heel for a virus, to require stagnant air to spread. If you could focus in on the stagnant air, you can get rid of the spread.
Thank you.
Dr. Blake, this is Chip Batson.
Hi.
First of all, thank you for all your work. I follow you on Facebook and Twitter, and it's been real helpful to have a local resource that keeps up with things for us. That's fairly straightforward to understand. A couple of questions about the monoclonal antibody cocktail. Is that something somebody could have a second time around if they reinfected?
It's, it's brand new to this market. So monoclonal antibodies have been developed for lots of different things, but not really for people who are already infected, to fight off the infection. And so they thought it could work, and it looks like it probably will, but there's a great many things we don't know. I would assume you could take it more than once. I don't see any reason why that wouldn't work. I still have some concern that the virus will learn how to escape. Of course, if it escaped from the 2 monoclonal cocktail, then it could just make it not useful anymore, I suppose. But I think it could be used more than once. But the bigger issue with those is going to be cost. Monoclonal antibody cocktails are going to be several $1,000s per dose. And so they're not going to be produced in infinite numbers. So they're going to be restricting them to the most vulnerable people but if you're 85 years old and you tested and you could get one of those, I would think that would be a great thing.
Do you think they'll get the emergency use authorizations they're trying to get for the cocktails now?
I kind of hope they don't, but it won't be very much longer until they have regular authorization. That is, the side effect profile is very mild. The efficacy seems very high. And so it won't take very long for them to get through the phase 3 trials, because they're governed by things like efficacy and side effects. And so I think that they're coming. There's at least 3 companies that are going to have them. And before we get to the end of this year, most of the most vulnerable people should get those right after they test positive. And I think that's going to make a huge difference.
Thanks.
Okay, well, it looks like we are about out of time. I want to thank Dr. Blake. It was really informative and educational presentation. And hopefully our members see why we have elected to stay in the virtual meeting format, given the information that he provided for us today. As he mentioned, he's going to send his slides, and we'll make sure that those go out to the membership. And we've recorded this, and we'll post it on Facebook and YouTube, so everyone who missed can see it that way. Or if you want to watch it again, you can do that. Our next meeting is going to be October 26th, and we'll have Daniel Stewart, the president of Weir Stewart, talking to us about the importance of marketing and branding. And I'm going to keep my campaign promise of not having a corny dad joke at the end of our meeting, as Jeff likes to do. Instead, going to just provide a quote for the week. Today marked the start of early voting in the state of Georgia. So I have a quote from what some would call maybe one of the first a political scientist on voting and political participation. It says one of the penalties for refusing to participate in politics is that you end up being governed by your inferiors. So take that to heart and make sure you vote, or if you've already voted, great. If not, you have 3 weeks to make sure you do that. So thanks everyone for coming. Thanks again to Dr. Blake for the information and the Zoom assistance. And we'll see everyone back in 2 weeks. And don't forget your charitable trust donations. And thank you, Amika, for kicking off that campaign.
Thank you,
Thanks,
Dr.
guys.
Blake.
Have a great week.
Thank you.